Hello! I've shown this OWI Edge Robot arm before, a USB controlled robot arm. Today we're going to get control of this robot arm via the web. We're going to make a small simple interface using Python and Flask. So what we're going to learn today, we're going to take a robot arm and we're going to get it connected to a Pi. I'm going to reference some earlier videos on what you need to set up and what you need to install. I can reference where that's going to be done. We're going to use a Python library Flask. We're going to create code to control this arm with a simple web page. In terms of coding, we are going to be working in Python 3. This video is for this OWI Edge robot arm. And I'm going to be using my own underlying ARM library. However, maybe this can be adapted to other ARMs. Let me know in the comments if you think a MeARM follow-up is a great idea, and maybe I'll do so. I do have a MeARM around, and maybe I can get some other robot arm. Before I get into programming it, I want to make a slight upgrade, slight adjustment to this robot, which is that there's all this cabling, which is kind of clipped in place, but a bit messy. And the thing is, I've got bags of this stuff. Hold on, let's hold it in front of one of the cameras. So this is spiral wrap, which you can wrap around wires while they're still connected, and it just gives you a great way to kind of keep things really tidy. I've been using it in some of my robots, especially the Pi-Walls robots. So let's put some of this on. So you wind on one end like that, and then you can just kind of wrap it around and round, basically. And it's not particularly tight, it doesn't put any stress on the cables. If anything, it takes some of the stress off when bunching them together and then stopping them getting snagged in things, which when things move, like in a robot, like a robot arm especially, you don't want your stuff getting snagged and caught up. So I have a big bag of this stuff, and beyond being able to fit it to existing cabling, it's got a couple of other superpowers. One of them is you can cut it to length, so I need a piece going from up here specifically down to this point here. So I can just take a pair of cutters, wire cutters will do nicely, and clip here. Now the other part is, because it's a wrap with exits, you can have wires that exit early, like these motor wires here. So let's start from this bottom end here. And this might be too thin a grade, but I haven't got one size. I probably should get a few different sizes of this. And I'll wrap that around. Now, I won't wrap it around the wires going to this local motor, this motor here anymore. And I'll just go for all of the rest of the motors up there. Now, I used this in my SpiderBot to tidy up the cables, and it came with the SpiderBot, and then I just found you could just buy this. It's quite good with the book robot as well, so although I don't specifically recommend it in the book, it's something you can definitely add. It's another kind of piece of bit of hardware extension. Simple one is to get some wire wrap, and for all of the connections to sensors, there's some that are already grouped in those ribbons, which are great, but even then, when you end up 4 or 5 ribbons going across, you can bunch it up in this, and it just makes all the connections on that robot a bit tidier, a bit more robust. So I thoroughly recommend that. If you're building the robot and learn Robotics Programming, the 2nd edition, then go and get yourself some wire wrap and wrap up the wires. And as you add more sensors and more motors and more things, it becomes even more relevant to get some wire wrap. The other thing you could do with wire wrap, and this is all black wire wrap, is you could get different colours, or you could put a splash of colour to show what the different connections are, so at a glance you can see. Now look how much tidy that is compared with what was there before. If you compare it to this other side here, where I've got this massive cabling here, a little bit of wire wrap is going to make that far tidier. It's always tricky with the camera because I'm trying to keep an eye on staying in shot while doing what I'm doing. and anybody who's making YouTube videos doing stuff like this will know exactly what I'm on about. They'll have definitely experienced the same thing. Okay, I would say that's a job done. I mean, that looks far tidier. You know, there are areas around these clips which are very handy, which are perhaps a bit less than tidy, and perhaps I could do something around here, but the majority of it is covered, so I'm happy with that. There are some things about this that I did find slightly annoying. One of the things I found annoying was that there were two blue cables with slightly different functionality, and I stuck a little circle of black tape on there just so I could distinguish that end and this end here. I've also got it, which wire is which. And there's also, I mean, so the other ones, they've color coded them. There's a red, there's a yellow, there's an orange, and the two blue ones are the same, and they're for the shoulder and the elbow. Oh no, sorry, the elbow and the wrist joint. Sorry. So they even go to a very similar place in the build, which makes them quite hard to trace out, right? Anyway, I think now we can get to how we're going to do the code. So let's start with the basics. What we've got here is a Raspberry Pi Zero. You could probably use anything, a 3, a 3B plus, whatever. Because it's a Zero, I have to have this OTG cable here to be able to connect to, and I'll make sure it is the right USB device. Talking of the OTG, there is one thing I find slightly troubling about this board, or at least using it with the Raspberry Pi Zero. So I've got this OTG adapter going out to this USB cable, going to this other adapter here. Now, I'm all for modular design, but I would really love to be able to mount the Raspberry Pi Zero like somewhere on the side of this robot, perhaps with a little power for it on the side. And then that cable starts to look unreasonable. So some future project, I think I am going to find a way to find a more direct connection from the Raspberry Pi Zero into the side of this robot. Maybe find out what the pinout is down here. I don't think the GPIO breaks out USB pins, but perhaps there's another way. If I can find another way in to do that, I will try. Leave some comments down below if you've got suggestions on how I might do that. This Raspberry Pi, it has a version of Raspberry Pi OS on it. Things you're going to want to do to your Pi before getting going. This has got SSH set up. So the WPA config file is there for my Wi-Fi. The SSH file is there to set it up so it starts SSH on boot. That means I can connect to it remotely. I haven't set up a desktop, so it's not using HDMI, and I'm not going to see any desktop. I'm not expecting anything visual from it. It has already got Python set up, and it's already got the code from GitHub that I showed in one of my previous videos on this particular robot. So it's kind of ready to go in a way. We just need to get the web code on there. Just so you can follow on a little bit easier, I will also be creating a page on the Orion Robots website showing how you can build this, or how you can write the code for it too. I'm not expecting you to follow all the code from the video, so you can use the two together to kind of get things right and to see how things are going to hold together. Okay, and we're going to need to power the Pi. We don't need to add any additional power for the robot because this comes with its own batteries down in here. I think they're great big C or D cells. Alright, Pi's coming up, so we'll wait for that to come up and we'll connect to it. And I'm going to connect to it from my laptop over Wi-Fi. So we have a Wi-Fi controlled arm. So this is only really tethered to power, and for the Pi you could just run that off some batteries if you wanted. Okay, I think it's time to get this thing powered up. It's turned on. These batteries, by the way, last nearly forever on this thing. And we're going to do a bit of recap and run some tests. So I have a terminal onto the Raspberry Pi. These all got defaults. You should probably set your own host name and reset the password, but I suppose I'm in my local network, relatively safe. And let's start Python 3. And we should be able to import USB ARM. Okay. And if we say arm equals USB arm dot, we want arm.usb arm, I guess. Oh, arm.usb arm dot arm. There we go. This should give us a connection to the arm. And I think then we can do arm dot, and we've done a list of things up there. Now, I probably want to explain how some of this code works on this arm. These are here, so grips open, LED, shoulder up, shoulder down. These are different types of movement you can send to the robot. They aren't functions you can call, and the reason that is so then you can send more than one kind of movement together to the robot. So you kind of connect multiple movements and send them in one go. So the robot has got 5 axes and a light. We will try, let me see, arm dot, and let's do just look at what's in our arm. There we go. So we've got arm dot safe tell. Now safe tell I think is used by move, so you want to make sure that the arm stops after a certain time, and I created a library so it would default to stopping after a second. Again, you don't want it to just keep moving until it pulls its cables out and destroy it. This robot has got no sensors, and without me telling it to, it will just carry on moving. So this code is written with sleeps and automatic stops built in. And if you're ever working with something that doesn't have sensors or isn't a servo motor, i.e. if it's got a servo motor, if it's got a servo motor, you can position it and say what position you want it at. This does not. This carries on moving any motor, as in you start a motor, you stop a motor, so you have to put in automatic stops with some timing, otherwise you'll go past the extents. But we'll say, so USB arm, which is the library name, and we'll do, let's try going elbow up, because the elbow looks quite far down. There we go. Elbow up, and we can, and you noticed it automatically stopped itself. There is a dot stop here. There we go, we've got a dot stop, so we could stop it manually, but move, I think it's a safer option. We can then say, we've got wrist up, and we can say 2 seconds. Nice. Now actually, what if I wanted to move the wrist and the elbow? Well, you use this operator here, the pipe operator, which in Python is an OR. So we're going to connect these together. These are actually bit patterns, so we're doing a bitwise OR in these. Well, there's a bit more to it. There's actually a class thing, so actually that is just the OR operator, not quite the bitwise. But anyway, USB arm, and we'll do random key presses, and we'll do that and elbow up together. And we'll leave it back at the default of, well, we can go for 1.5 seconds because you can use a decimal here. And they move together. And it's moved out a shot again. We don't need to shoot the battery, do we? We just need the fun bit. So if I angle the arm like that, you can see as much of the arm as you can. And I can try not to destroy it. We can do arm.move USB arm.LED on. And we've got an LED. And you can then start to chain things. So you can say arm.move LED on, arm.move USB arm. I've got, notice I've got grips open and open grips. I came up with some synonyms for things just because I kept using one and meaning the other, and I just went, yeah, I'm just going to have both. So we'll open the grips, and we will move that elbow up a bit more. Okay, and so then we can say arm.move, and we'll try the base as well. So if we do USB arm.base, we want to go counterclockwise. And I called it CTR clockwise. Maybe I should do more of those synonym parts. Okay, but this should do a sequence of maneuvers. Light on, moves up, There we go, the sequence. Alright, but that's not what we're here for today, that's just a test. So we have seen, I think, we've seen this motor move, shoulder motor. Did we do shoulder? We didn't do shoulder. Let's test the shoulder just to make sure I've not messed with any connections up. We'll do shoulder down. So we've seen the base, the shoulder, the elbow, the wrist. We have seen, and also the grippers. So we've seen all the motors and the LED move, which is a good sign. Probably worth testing before we get in, since I have just got to wrap the cabling and I could have pulled something out or something like that. So now we know all of the moves, so now we can get into the Flask coding. You probably want to do some simple as you can tests on your robot before you get complicated, just because you want to know all the parts still work, especially if it's been in a cupboard and collected this much dust. Ew. Right, I'm going to exit Python here and let's have a look at the code, shall we? Before we can use this Flask thing to interact with our robot, we need to install it. So that is pip3 install Flask. And I'm sort of cheating here because I've already done it on this machine. Yay! When it goes, it really goes. Okay, requirement already satisfied. It took a while to tell me that though. Let's do some very, very simple code just to get us going. Again, start with the smallest thing, build upon it. So we've got the input for the USB arm, which we've seen before. And actually on this line down here, we're creating our arm. We're also importing Flask. So Flask is a Python web server, so it will accept requests from HTTP, that is from your web browser, and send responses. It can do a load more of stuff with it than that, but that's basically what it does. When it accepts requests, it routes them to functions. So we've imported Flask specific items like the Flask object itself and the response object. And so after initializing the arm, so we've got some hook to talk to the arm with, we then create the app, and we've given it the name of arm hello. I mean, that's up on the top line of the editor up here. So we called it arm hello, and that double underscore name means it's going to call itself, this server, arm hello. So Flask has this concept of an app making routes. That is, you route a particular web address on the server to a particular function in Python. And so that's routing top route to a function called flash, which is just going to flash the light. Its indentation is wrong. Let's fix that. That will do nicely. So this has actually got an inner function and an outer function, and I'll tell you what's going on there. There's some sneakiness going on here. So it's going to get called when this route is hit. Flask can run something and then send you a response when it is done. So the simplest Flask thing actually would be here to return hello world in a string. We need something slightly cleverer than that, because we need it to start a robot action, to tell the browser it's alive and has started, so the browser doesn't think it's just timed out, and then we're going to send something to stop. And the way you do this is to use the yield keyword inside our function flash, which flashes the LED, and then returning a Flask response wrapping this inner function, which we call here. Well, this inner function doesn't have a return. Each time we yield, it sends a little bit of data back. And that little bit of data goes back to the response, and the response will send that little bit of data back to your browser. So you'll actually see things happen step by step. You'll see the response with the LED going off, and then you'll see the starting. This BR thing, it's a break. So if you're not familiar with HTML, this is just a way to tell it to go to the next line. And then a completed to show it's done. And the very bottom line here tells it to actually run the Flask server. 000.0.0 is the host address, and it's a special address. It means that the Raspberry Pi will be listening on any of its incoming interfaces. Now, you could put the specific IP number that this Raspberry Pi has on its Wi-Fi or whatever you've connected it to. That's going to be frustrating because you have to go and find it each time. 000 basically means I'm going to listen on all interfaces for requests to this. So in the case of this robot, that makes sense. Maybe you might want something more specific if you're doing something more pro, but I think for this case, that makes perfect sense. So let's try and run this thing. So hit Control X and save it, and arm hello, and we will do Python3, because we're in Python3, arm hello.py, and wait for it. And now it's telling us it's listening on port 5000 on that 000 interface. Okay, so we've got a nice blank browser here. Okay, I guess we're ready to run this thing. Now, the way I've written that code is the act of going to this server is enough to start it off. So if I go to Raspberry Pi.local and it's on port 5000, you'll spot that it's predicted 5001 because I've got other things that were. And what will we see? Starting completed. The light went on and it flashed and it said starting completed. Maybe we have to see it do that again. So we should see the message started arrived before completed. It's kind of a bit too quick to see what's going on, but it is sending data before it's done, so it can actually do this, I guess, this longer operation. You notice I've popped these /ns on the end, which actually makes sure the client will flush it to the screen. Otherwise, it'll just sit in a buffer till the end of this, which is not what we wanted. We'll go and test this. And we're going to test using curl, which is a command line client for testing web interfaces. You'll see in Learn Robotics Programming 2nd edition, I used it a lot to test the various web-based services on the robot before putting in a full front-end UI, because full front-end UIs can be kind of complicated, whereas testing with curl, you keep everything as simple as you can. And just like we have done before, keep working in small, simple steps. Right, let's go across to curl. So let's start the service. And it takes a few seconds. There we go. And now we create a curl command line which goes to Raspberry Pi.local port 5000. If the other side tried to talk to 0.0.0.0, that would be any device on the Mac. So that's not what we mean. So if I hit enter here, we're going to see it echo a message, light the light, and then echo another message when it finishes. So echo a message, lit the light, and done. Okay, that was over in a bit of an instant. It's about a second, but you can see the messages come through in a sequence, so it can handle that the robot is going for a second and stopping. And we can see the BR, that's kind of intended for a browser. Right, so now we've seen the simple server, it's time to look at the more complicated one. So we've got the usual imports, except we've got, as well as response, we've got the request import, because we're going to be looking at some request data here as well. We're going to use that to choose our movement. We initialize and set up the ARM, and we initialize and set up the Flask app, just as we saw with the Hello World app. Here, however, I am mapping a bunch of stuff. So I map a name like grips close to the actual bit pattern for grips closing the grips. And I do that for all of the different arm movements. That's so I can reference them by name from my web request to it. And then after all of these, I have my one route. This is a one route, single route server. Really simple. And the one route is move. So if I do /move, it's going to hit this route. And this takes it takes a list of methods. Now, there's actually only one method in that list, and methods are how we communicate with web servers. So when we did our Hello World, we were doing what's known as a GET request, which is actually really only supposed to be used for getting data. In this case, however, we're using it for sending data. We are pushing data at a server. We want it to change something. We want it to move the actual robot. And sometimes it's not going to do if we just use GET requests, and that's for a number of reasons. When you change data, you say you're posting data, that's actually a message to the server, I intend to change something. That also says to other things in the way, be it your browser, be it other kind of interesting bits of network hardware, don't cache this, don't keep a copy for later, I'm making a change, so I want my response to be fresh. Which in the case of a robot means you want it to actually make the adjustment to the robot. Otherwise, you might find it gives you a non-fresh response and it's not actually sent anything to the robot. This is very, very frustrating. It's happened to me before. There's also more about that in Learn Robotics Programming 2nd edition, where we use post requests with some of the JavaScript, where you make some interesting front-end UIs. And making sure we use post requests when we mean to change data is important, so the data is actually changed, the robot actually gets the message, and so it doesn't just forget you asked it. This has mapping through that list we showed you above, that map above, so it maps a bit of form data we give it called pattern to an output that is the pattern that's now been mapped through our list above. And we then have a starting we make the movement, and we have completed. So again, it's similar to what we did with the LED interface. Fairly simple. We're still going to keep it simple because user interfaces are fairly complicated. We will just hit this with curl. Okay, let's go and get the web server up and running. And I'm going to leave the window open here with the editor because I feel like I'm going to need this map to get to it. Right, the web server's up and running, and I think we're going to go back to using another terminal to run curl in again. So we've got a slightly more complicated curl command line here, and what we'll need to do, so again, we'll do curl and we'll do http :// Raspberry Pi .local 5000, everything we did before. But now we want to change its method because it's going to post some data. So we've told it curl is going to post some data, and now we need to tell it what is it posting. Well, we wanted some form data. Oh, that's supposed to be a minus. And we wanted to send a pattern. And we're going to do, I know this is a bit boring because we've got this to work before. We're going to say LED on. Okay, so this should tell the robot to turn the LED on. And, 404, what did we do? I know why we got 404. Because we've not got anything on the root here. It's on /move. And there we go. It's gone and turned the LED on. But now what we can do is you can swap this for any pattern. So if we do elbow down and I hit enter. And so what's happening is this top terminal here is on my computer sending data across to this Raspberry Pi over here, which is controlling the arm. So this is via the web. I mean, this kind of works. It's still a touch dull, but it's kind of working. But what I think we really want is perhaps to be able to change it from a button clicker. So we want to have perhaps a list of buttons that we can click. Well, we've already got this map, so we can use this map to make the buttons we're going to click. Okay, so we probably want to make this a little bit more fun and at least have something we can click at. I'm not going to make this too complicated, it's going to be a list. If you want to get to fancy buttons and sliders, Learn Robotics Programming 2nd edition shows how you can use CSS, JavaScript and HTML to make really kind of much more fancy buttons and slider menus. But we're just going to make a list of things you can click here. Alright, if you start getting more complicated with your output in Flask, you probably want to delegate to a template. So a template is like a bit of HTML with some placeholders, and you can change what those placeholders are doing. So we're going to say render template, and let's just scroll down, and we're going to need another root. So app.root, and that's going to have its default method of get. So we'll say def index because it's going to be the index page, and now we'll say what we're going to do. So here it's going to be a render template, and we will name a file. We're going to need to create this file later. Index.html, and we're going to give it a context as well. So to do that, we'll provide our list of patterns equals, and I think I called that move map. Maybe I should just call it patterns. Okay, but we're going to call it patterns. And so this little bit of code here, we're just going to get a page back based on that template. What are we going to do in that template? That's where it gets a bit more complicated. We're going to need a directory called templates. Okay, and we're going to need a template called index.html. And remember, we called our variable patterns. We're probably going to want to do some interesting things in this code, but we're going to start by just showing the list, and then we'll make it do something active a bit later. So I'm going to be well behaved and actually put it in an HTML tag. You don't really have to. I mean, you should. And I'm going to create a body to put our template in, and yeah, unlike the other examples, I'm building this on the fly. Wish me luck, people, wish me luck. We've got an ordered list. I'm going to stop using the tab key and use 2 spaces because that's going to go too far across. Python habits die hard. Okay, well this would be a list that would have hello world, right? And this would just create a page that said hello world. We wanted to do a bit more than that. So I'm probably going to go a bit fast on this, but for a slower version, the website will show you, and for more detail and further experiments, then Learn Robotics Programming 2nd edition has a very similar program for launching the different robot behaviors. Okay, so we will say for name in patterns, we only need the pattern name, we don't need the rest of it. And then we can say name here, and then we can do, I think it is N4. Endor? No. N4, like this. This should give us, when we run it, a list of all of those pattern names. Okay, that server's started. So if I go back to Raspberry Pi 5000, we have a list of items. Awesome. We might have to do a bit of work to convert those to links because I can't actually do anything with that list. You can't see my pointer anyway, but I can't click on these items. To make something into a link in a template or in a bit of HTML, we need to make a href, which is a HTML reference, an anchor tag, something that says there's something to click here. I'm going to put in a hash mark here, and the reason I'm putting that hash mark, aka a £, is because there's going to have to be a bit of JavaScript to go and send our data via the post request. But this will at least just make it look like it's clickable, even if it's not going to do anything at all. So if I write this out and rerun my server, and these all look like they're clickable. So now we need to be doing some more interesting stuff with this. I have a favourite way to post data back, and it's a favourite way that I use in Learn Robotics Programming. It's a favourite way that I use in various workplaces as well, which is to use the jQuery library. It's not a new thing. It's I think it must be getting on at least a decade and a half, maybe more now. But it's just an incredibly easy way to extend JavaScript to make some things really simple. So I'll also give my robot arm a title. Let's just do that here while I'm here. So robot arm, so now it doesn't just say Raspberry Pi local, and we'll close the title tag. But we're also going to load the script for jQuery, and if you'll excuse a copy paste, I'm going to just paste in that location. There we go. And that's actually a version of jQuery. We're loading it from the internet, so we don't need to host it on the Raspberry Pi and serve it there. It's just being served from a place on the internet, a CDN if you want to get technical about it. Okay, now we've got to change this. So at the moment this is a link, it goes nowhere, it's just got a name on it. Okay, well we can get a bit fancier. So we can create an on-click handler. On-click equals, and $.post is what it's going to do. So inside the quotes is the thing it's going to do when it's clicked. $.post belongs to jQuery. So generally when you see jQuery, if you see $. In the JavaScript, it means it is asking jQuery to do something for it. So it's telling it it's going to post some data back to our server, and we're going to post it back to the relative address move, and we're going to post a pattern. This is just like in curl when we said we were posting a pattern. And now I could put a specific pattern, but we know the name of our pattern, so we can now say name here. So we can use the same name that we've rendered in the pattern there. Okay, and that's gone into our post. We need to close those braces. We need to close the brackets for the .post, and we need a semicolon to finish that JavaScript line. I know, there's quite a lot going on in there, but that now means there is a little bit of JavaScript that will post the name pattern, or the named pattern, through the move location back to our robot. Okay, here we go. Let's do this. So I will exit and write that out. Maybe I should have kept that open in case I need to make changes to it. And in another window, let's start the server. So it doesn't look an awful lot different, but let's just click LED on and see if it's going to do the thing. It did the thing. Okay, base clockwise, counterclockwise, wrist up, wrist down. Can close the grips. Oh, maybe. Oh, we want to close them. They were a bit too far open. That's a horrible clicking noise, isn't it? There's no sensors, so it won't stop when it needs to stop. We can do elbow up and elbow down. Shoulder up and shoulder down. Maybe that should be shoulder back and forward, but you know, semantics. Can't remember how far that'll go. I think that's getting close. And I guess if we do that, so we do shoulder down and elbow up, can I make it point directly upwards? Just going to move it so the camera can see that. There you go, it's pointing to the sky. Awesome. I can hear some things clicking here. Possibly some of these cables are a bit strained. Yeah, that one's wrapped real tight. I'm just going to pull that through because we don't want any tight cables on there because that will damage it. Okay. Oh, you can't see that. That's the wrist moving. Oh. I'm holding the camera because unfortunately... Oh, right, didn't want to do that, did it? So there's not much movement in the wrist. But we now have a web page controlling our robot. Now, the thing is, if my computer can do it with a web page, my phone can. It's on Wi-Fi, my phone's on the same Wi-Fi network, why not? Now, there is one slight affliction when it comes to Android reaching these things, which is sadly, those lovely .local addresses do not work on Android. That means you have to use the IP address of the device. Shame, but okay, since we've got a terminal there, we can get that fairly easily. So I'm going to exit this here, and if I do an ifconfig -A, it will show me all the interfaces. These are the ones we referenced with a 0.00. So we've got LO, which is a local internet address, 127.0.0.1. This is every device has a local address that points back to itself. Then we've got WLAN 0, wireless local network 0. So this is the Wi-Fi. This is the address we want. We've got two addresses here, and well, we've got three. In fact, we've got an iNet and two iNet 6s. Not going to do the IPv6 addresses because I can't remember that. What I can remember though, 192.168.1.246. So that's my local network. So if I go and put this in here, we do 192.168.1.246 :5000. Here we go. Let's put this where camera can see it. Oop. Gonna put it there. There we go. And we have this. Ooh, and it's incredibly tiny because I've not particularly styled it for phone use. Again, this is something in Learn Robotics Programming you'll see. Oh, that's interesting. It's reflecting rather badly. So there we go. If I put it on this angle, we can kind of see. And if I do wrist up, then it nearly pokes me where I've got the phone. If I do base clockwise, I want to go counterclockwise, don't I? But now I'm controlling it completely wirelessly from my phone using the web code we've just written. I wonder. quite. There we go. It's holding the phone. I might have to catch this. I'm going to say my book, Learn Robotics Programming, 2nd edition, is now on sale. It has lots of stuff on building a rover robot, that is a wheeled driving robot. It uses far more sensors. This has no sensors. It's actually senseless. It just moves when you tell it. Whereas the robot you can build and Learn Robotics Programming, it knows how far it's moved. It has obstacle detection. It can track faces. It can sense coloured objects. It can sense which direction it's pointing. So it can tell whether it's north or whether you've tilted it. So it can do all of these things, and you'll learn how to build it, how to write the code for it. You'll see how to create, well, something like we've just created, where you take control of it with your phone, except it gets a bit more fancy and you get sliders and you get interesting coloured stuff. And the camera, you get to view things through the robot's camera, including watch when it is tracking objects or lines or faces. So that is Learn Robotics Programming, 2nd edition. And a link to that will be down in the description as well. So I will make sure that this code is somewhere on GitHub. I will make sure there is a link for it down below. If you have any questions, anything you perhaps would like me to revisit or to try, again, let me know in the comments. There will be an Orion Robots blog post showing the code and talking through some of the things I've done here. There is also going to be cards linking to the other earlier videos where I got this set up and maybe take you through the USB ARM library. And I hope you've enjoyed this. So thank you for watching. Go make stuff and be awesome. Bye. Bad idea. I mean, we've now been through how we'll... So now we've been through how we will interact. So before we can start using curl to test things, we're going to need we've got our methods equal to post, so we know what we're going to actually be sending. Do we want it to just go somewhere? So that is Learn Robotics Programming, 2nd edition, excuse me, in almost no time, depending on your network. So let's make this a fairly standard template, fairly standard HTML template. Oops. Now, it's, what can we say? We can do, okay, right, I'm going to put the robot, I think, this way up. There we go. That way you can see me and you can see the robot. You could see the Raspberry Pi too, but there's not a lot to see there. It's still going.